Welcome. In this lesson, we're going to focus on one type of function, the linear function. So we're going to always talk about linear functions, which means this really should be a review lesson for most of you, because it's literally y equals mx plus b. We'll have some constant rate of change, so the slope won't change. We'll have some y-intercept, and what we're going to realize, and again, the reason I actually am assigning this, I want to emphasize or reteach that there are multiple solutions to a linear function. It's a relationship between inputs and outputs. If I give you a 1, there should be exactly one output that goes with it. And what is that output? Well, the function here tells me what that output should be, or at least helps me calculate that output. I plug in a 1 for this x here, I add 1 to it, and I get an outcome or a y value of 2. And then you guys are going to fly through this because I know you're smart. We're just always adding 1 to whatever x is. So if it was a 2 that I started with, it would end up being a 3 for y. If x started as a 3, then the y would end up being a 4, and so forth. Just watch the numbers. It looks like they skip 6 here, so I go all the way up to 8. Then not only do they want you to fill in the table or realize that there's multiple points or multiple ordered pairs that make the equation true, they have you graph it. So we come down here to the graph, and you really only need to graph 2 of the points. I'm going to graph the point 1, 2 and the point 2, 3. So 2, 3. And it graphs the whole line for you. If I tried to go to 3, 4 and graph that as well, what it does, it unclicks the last point I did. If I tried to go out here to 4, 5, so if you see, it's just redoing the points or moving that second point further along the line. But I like to compare to make sure I've done everything correctly. And that's this lesson. It's just simply y equals some slope times x plus b. Or it's a function, though. We're focusing on them being functions, a relationship between input and output that has a constant rate. So I'm really just going to let you guys go ahead and do this. I am going to jump ahead just to make sure I don't see anything now. The numbers get bigger, but that's perfectly fine if they get bigger. Just make sure that you take the time to do the math correctly. I have a -3 slope, this -3, that I'm going to times by an x value of 5, which I then add to 25. So a lot of students, they just start dropping their minus signs. So I'm going to have a -15 plus 25, and -15 plus 25 is 10. So this value right here becomes 10. Now what's nice is if I go up by 1, I'm going to go down by 3 because this is the slope, -3. If x goes up by 1, I minus 3 from the y value. I could take the time to plug the 6 here, get -18, add it to 25 and get 7. But I like to just minus 3 every time, as long as I'm changing the x by 1. Now again, go over here, grab a couple points. So 5, 10 was the first point, and 6, 7 was the second point. And just to verify, I'm going to come down here and make sure I got 7, 4, and I did, and I have my solution. If you have questions on any of this, please do bring them to class, but I do believe most of you will fly through this fairly quickly. Be careful of horizontal lines, or the function that's horizontal. You'll never get x equals a number because a vertical line is not considered a function. It's the one type of linear equation that's not a function. That's the vertical line. But horizontal lines are perfectly fine. We're always saying that y is -5, no matter what x is. If I say x is 5, y is -5. If I say x is 8, y is -5. If I say x is 10, y is -5. And so I come here and graph that down here at -5. I don't even have to graph the points they give me. I can graph any point I want as long as it's on this horizontal line of y equals -5. Again, bring your questions to class.